Hello everyone, my name is Yui, and today I will present about how to design a project for assignment 2. I have divided my presentation into 4 main parts. Firstly, I will introduce about this assignment, how to use Prosper. Secondly, I will show how to input data in this software. After that, the result will be showed and calculated. Finally, I will give you some conclusion and evaluation about this assignment. Now, let's turn to first section, assignment details. Well modeling and artificial leaf designs are regarded among the core tools in production engineering, especially for well performance and production optimization. Prosper is a well performance design and optimization program that is part of the Integrated Production Modeling Toolkit (IPM). Prosper is designed to allow the building of reliable and consistent well models with the ability to address each aspect of well-born modeling, such as PVT, VLP, and IPR also. This tool is industry standard for well modeling worldwide, and in this assignment, I will use Prosper to set up the basic models, which require first characterization, PVT, IPR, and skin modeling, VLP construction and matching, and finally artificial leaf design or optimization. So now let's turn to the first input data. At the beginning, I will create the IPR curve first. Supposing in this well, the flux is oil and water here, and I apply the gaslit methods in this curve. After that, we need to input some parameters such as gas-oil ratio is equal to 1000 cubic feet per STB. Oil gravity is equal to 41 API. Gas gravity is equal to 0.798. Water salinity is equal to 80,000. And then you will click match data and calculate until the PVT here is matched. So, when the PVT is matched, I want to check the pressure by automatic calculation of this well. It shows that the pressure is from 1000 to 5000 psi, with the temperature is between 230 and 350 Fahrenheit. Then I will check the inflow performance relation IPR by choosing the reservoir models is Dodgy with the skin factor is changing by the input data. Then I plot the curve of IPR. So here is the result of IPR curve and can be seen from the graph. The absolute open flow is 4817.8 STB per day. Then the skin factor here is equal to 0. Furthermore, when the pressure drops down, the flow rate is increased from 0 to absolute open flow. Also, at the same trend, when I change the reservoir pressure into 2000, 3000, 3600, 5000, 6400, with the same trend, the new IPR curve will be shown. As the figure, the curve is straight at the beginning until the pressure is equal to 0, but the line is slightly curved at the end of the string. Next, I want to calculate the data with 3 variable system. At this part, I input the top model is 1000 psi with the total GR is equal to 1000 cubic feet per STB. Then the methods here will be red and blue method. Then I have the calculation table show that the change of VLP pressure change in the IPR pressure declines. Here I consider the reservoir pressure is 3600 psi. After you have input the data, you will have the graph show two curves with the green curve is IPR curve and the red one is the VLP curve for the pressure at 3600 psi. At the same with the previous way I have done with the IPR, I will track the flow rate with the different reservoir pressure from 1000 to 6400, which is inputted by hand in the figure here. Here you can see that the graph shows the combined chart between IPR curve and the VLP with different IPR in pressure. It can be seen that the VLP cut the IPR from the pressure number 3800 until the 6400 psi. Here you can see obviously that the IPR did the cut two lines 0 and 1, so at this point, to take the oil from this well, you should pump more water so that the pressure in this well will be increased. Then the oil will be easier move out, and after that, you should check the environmental conservation in the petroleum industry. At the same figure, but different in skin factor, you can see that with the same pressure but different in skin factor, the flow rate tends to be decreased. Here you can see clearly that when the skin factor increased from 0 to 5, the flow rate decreased slightly. Also at the same method, but different in pressure, the curve about IPR and the VLP is generated. At the figure you can see clearly that at the pressure of 3 and 4, the trend is stable, and it's so important to maintain the inner wheel. So now, let's turn to well design. So in this part, I will show how to design a simple well and gas lift design. First one, I will click the design tool in the toolbar and choose deviation. Then I will fill in a table with the depth 0 and 5000 respectively with the same value in the true vertical depth. Next, I tick on the tab equipment. There are some input data such as survey equipment, downhole equipment, geothermal gradient, and average head capacities. Then I consider the overall heat transfer coefficient. In this well is 8 BTU per hour per feet square per Fahrenheit with the same unit parameter that have I chosen. Continue, I choose the coefficient of oil and gas is 0.053, 0.051 respectively with the coefficient in water is equal to 1. By clicking the summary button, Prosper will show the brief table about Christmas tree and topping parameter with each value of each column for each column. Then I will design them by click on draw downhole button to show the well figure. So here is the figure about a simple well with the upper part is Christmas tree and the lower one is about the topping. As the figure here, the Christmas tree is on the surface. Furthermore, I want to calculate the gas lift of this reservoir. So on the screen here is the input table with the flood is oil and water, but the method is used for black oil. In the well, the flow is topping flow, and this part is calculated by gas lift method with friction loss in annulus. Then I input the gas lift. Gas gravity is 0.955 and GLR is equal to 500 cubic feet per STB, and I choose the gas lift method with the fixed depth of injection. But in the assignment, I want to calculate the data from the mass production with the maximum click rate is 720 STB per day, and the total of GOR is equal to 1000 S cubic feet per STB. Then, after all, you will have the result here with the temperature increase with the depth and the same with the value. So, in the assignment, I have to show how to use Prosper and calculate the IPR and the VLP curve with different pressure and skin factor. As can be seen from the previous slide, when the skin factor increases, the flow rate decreases slightly. Furthermore, I have already designed a simple well by using gaslit method. It also shows that the pressure will increase and the temperature also go up when the depth tends to be higher. All in all, Prosper is useful software for engineering to solve some problem in this measure to support the engineer well. So thank you for listening.